Hello everyone. Hi, my name is Fiona. Thank you so much for waiting. I can see some of you are still joining, so welcome. Welcome to our virtual night sky tour event. We are live on Zoom, so welcome to those of you that are watching on Zoom and also on YouTube as well. So I'll talk about this at the end, but this means that you can share this video with your friends, family, and you can watch again later. So hello, welcome. Please do let us know where you're watching from. I think I saw that someone's watching from America, which is brilliant. So we do have an international audience, which is fantastic. I'm based here in Scotland, in Edinburgh. I normally work at the Royal Observatory, which you might have been to visit before. It's a very beautiful place. At the moment, you can see I'm actually at home, but usually I'm up at the Royal Observatory. So just a couple of things before we get started. You might already know this because you use Zoom all the time, but just in case, you can see that Kieran is in the chat. So Kieran can help you with any technical problems if you can't hear, things like that. Just let him know. You're all letting me know where you're watching from, which is great. Nottingham, Canada, fantastic. Hello, everybody. Colorado, brilliant. Also, we have live transcript subtitles. If you do want to use those, they're there. They're auto, they're live, so they might not get it quite right. They're quite entertaining. But if you want to turn them off or change the size of them, there should be a little arrow next to the transcript button, and you can change those or remove them completely. As well, you'll see you have a Q&A button on the top of the bottom of your screen, and you can submit questions to us. We might have a little bit of time at the end, but most of this is going to be a tour of the night sky, obviously virtual, and a little bit of a chat. So this is a bit different to some of the other events you might have come to if you haven't been to one of these before. So it's not like our talks, it's a chat throughout between me and somebody very special who I'll introduce in a moment. And we're going to use a program called Stellarium to take you on a tour of some of the things you can see at the moment later on tonight, or it depends where you are in the world, what time it is at the moment, but here in Scotland later on tonight, and also at this time of year. And I think I should just introduce my special guest, actually. Let's introduce Megan, who is hiding in the background somewhere. Hi, Megan.
Hello, am I connected now?
How are you doing?
Not too bad, thanks. Yourself?
Good, yeah. It's very sunny in Edinburgh at the moment. So
unusually, yes.
Yeah, it's sometimes sunny in Scotland, but not very often. So it's a beautiful day here. So it's quite nice. We're all very happy about that. So I'll introduce Megan as an astronomer at the Royal Observatory. Yeah. Does that sound right? Yeah.
Sounds right.
Yeah. So Megan, how long have you been working at the observatory actually?
Almost 3 years now.
Okay. Quite a while. So Megan's going to, whilst we tour the night sky and see some of those things to look out for at the moment, some of our favourite objects, Megan's also going to talk about some of the things that she explores in the universe, some of the work that she does, which is very exciting. So I think we're ready to go. I'm just going to share my screen so you can all see what we're doing. So if you just bear with me a moment. Here we go. And whoops, oh, I was nearly there. Back again. Okay, so
that looks good.
Yeah, can you see the sky? Not the real sky, of course, the virtual sky. Does that look okay?
Beautiful view to me.
I mean, this is the weather we have in Edinburgh today. So usually we make a joke about this never happening, but right now it's actually like this outside. It's quite nice. So almost like a view of the outside today. So just looking across the city of Edinburgh, you may have been to Edinburgh before. If you've not, if you get a chance to come and visit when we're allowed to travel the world a bit more, please do and visit the beautiful city of Edinburgh. There's lots to see. This is the Royal Observatory rooftop. So just over here, you can see this is one of the telescope domes. They're Victorian built and they've got these very beautiful decorations. So we've got one over to the east and also one over to the west. And we're looking just out to the north at the moment. So the program Stellarium, I should have said you can download this for free at home, have a play around yourself, but it's quite handy because unlike in real life, it's got an N for north here. So we know which way we're facing, which is good. And also we can see a couple of things. that you might recognise. Handy labels here for everybody. This is Edinburgh Castle, just poking out here in the city, and also Arthur's Seat, which, have you been up Arthur's Seat, Megan?
Yes, steep climb up and very steep climb down.
They call it a hill, but it's, you know, it's still pretty big.
It's just straight up though, straight up.
Straight to the top. So yeah, you get a great view there, but I think we've got a pretty good view from the observatory as well. So we need to fast forward time a little bit to nighttime. So you can see we've got a handy clock down the bottom here on our toolbar. So that tells you we're at the real time at the moment in Edinburgh, just after 6 o'clock. On the 22nd of April today. So if you're watching this a little bit later, we're going to see the sky as it would be tonight. So I'll be able to fast forward time for us and we can get a lovely sunset. Here we go. So whilst we do that, I noticed the chat in the background is whizzing away, all sorts of things happening. I'll have a look in a moment. But I wanted to ask you a question, Megan, and also everybody watching at home. Don't worry, we've prepared for this. So what do you love about stargazing? Is there anything particular you like about stargazing?
So I think I'm always surprised by it. So as a kid, I thought it was really boring and kind of cold and cloudy and didn't really see what the fuss was about. So it's really only as an adult that I've been able to go to places that are dark enough that you can see more than just the brightest stars. And that's been really impressive to me, because the longer you stay out, the more you can see as your eyes adjust to the darkness and you can start to see fainter stars, and even some of the fuzziness of the galaxy come out. And there's just something so amazing about actually being able to see that with your own eyes and be like, oh, no wonder they called it the Milky Way. How else would you describe that kind of fuzziness in a way that I never knew that before. So yeah, it's very rewarding, I think.
Yeah, I think at the moment, just with everything that's going on in the world, it's really nice just to take a moment to, I guess it's a bit of mindfulness in a way, just looking up at the stars, taking it all in and just seeing the bigger picture. Like, I'm just thinking back to a few weeks ago when I spotted, I think it was Sirius, the star Sirius, and it was flickering, and the colours that it shows as well. And it was just so beautiful, and just looking at that out of my bedroom window, you know, just looking at the night sky for a little bit, it just kind of took my mind off other things that are happening. So it was a nice quiet moment. So I think stargazing, although you have to go out very late at night at the moment, it's worth doing, and the more you look, the more you see, and there's always things to learn. So someone in the chat, I'm just having a little look. Marie says she's in a dark place where there's and she doesn't use a flashlight and walks at 3 a.m. every morning just to be out alone with the stars. Marie, that's amazing. Fantastic. Yeah, I mean, if you are up at that time, even if you're not, just getting up at that time, you know, once, you know, obviously if you're a bit younger, get permission from the parents and go out with an adult. But yeah, having a little look, and it is much better if you manage to get out of the city. That's great. Yeah, it's really, really good. So if you don't do stargazing, maybe this is something you want to start doing. I mean, summer, as I said, you have to go out later, but it might be something you want to pick up as well later on in the year. So let's get back to the stargazing. Okay. So someone else says, once you see the Milky Way with your own eyes, I don't think there's any turning back. I love that.
I think that's true. I think it is.
Fantastic. So we're going to have a look at some patterns that you see all year round. So you may know we call these circumpolar constellations. Okay. So I'm just going to minimize the chat so I can see everything. There we go. So one of these that you might know is this one here. So let me pop, there we go. So handy in Stellarium, you can put up some lines, so you can draw those dot to dot lines, and also you can put up some art as well. This just shows you how ridiculous constellations are. I mean, this is Cassiopeia. We may have met her before. I mean, it's a W, it's a line in the sky, those bright stars. So you're looking for a W shape really, but it's actually a lady sat on a chair looking at herself in the mirror. So, you know, that's what it's meant to be. But I think we'll stick with the W, or depending on where it is, it might look like a 3 or an M as the stars move around, or as the Earth rotates rather, and the stars appear in different places. So here we are at Cassiopeia. We're looking north, there we go. So the handy thing I must say about Stellarium is you can add in, like we put in our view from the rooftop, you could put in your garden or a panoramic view of where you're going to go stargazing, and you could see, oh, I might not be able to see that then because there's a tree in the way or something. Quite handy. So you can prepare for things like that. But Cassiopeia, we're going to use that as a pointer to another constellation. Okay, so we're just going to move to the east, so over to the right here, and this is a summer constellation, and this is one of my favorites actually. It's part of the summer triangle, which you can just about see at the moment. It's just rising up in the east. You see we've got the tower in the way a little bit here, but over here we have, this is Cygnus. So this is a swan. There we go. There it is, flying across the sky. And also up here we have this very bright star. So this is Vega, and this is one of the other patterns in that group of stars called the summer triangle. So we've got the bright star in Cygnus, the bright star in Vega, and then one other one. So we'll probably talk about the summer triangle next month, so I'll hold it there. I'm not going to say anything else, so tune in next month. But Vega is part of, this is like a harp, this instrument. And another thing to say whilst we're here is, I think, tonight and early tomorrow morning. So maybe, is it Marie, if you're out at 3 in the morning, that's probably a good time to go out about and see this. If you're out that late or early, whichever way you see it. You can look for the Lyrids meteor shower at the moment. So it's actually peaking very early tomorrow morning. So there's not that many, and you'll see the brightest ones. But if you have time to go out and, find a quiet dark spot, if you're lucky to live somewhere like that, you might spot one. So it's worth looking, and it's around this pattern here, this very bright star, which is Vega. Now, Megan, I think there's something that you wanted to point out in Cygnus, but I can't see anything else there apart from the stars. Is there something lurking?
Is it something that's perhaps hidden?
Maybe, yeah.
Something our eyes can't
tell
see.
Me. So we do, the thing we can do with this is we can annotate. So what I'm going to do, it's a bit like, we'll go into art and science now. And do you want me to zoom in a little bit, or are we okay there?
I trust your judgment.
Okay. Right, so we'll stay here. So whereabouts do we need to look, and what are we looking for? It's something that we can't see with our eyes, but there's something hiding there in Cygnus. Is that right?
Right. It's just off the Swan's Neck. Does that sound right to you?
Yeah. So I think we're about here somewhere where these 3 stars are. And what's lurking there that we can't see?
So in the Cygnus constellation is the Cygnus X1 black hole. So this is one of the first sources in the night sky that we saw that really seemed to be looking and acting like a black hole. And it's weird. I realized I said it looks like a black hole, but by definition, right, you can't see black holes. So some of our best indication that a black hole might be there is what's happening to the stuff around it. So Cygnus X1, because it's a bright source in X-ray radiation, and we're trying to figure out, well, why is that so bright? It's much too bright to be a star. But it turns out that there's a bunch of stuff falling onto the black hole. So right before it falls into the black hole, it gets very, very hot. So it's very bright in the X-rays. So we discovered this bright X-ray source and trying to figure out what it could be. And so it's kind of been a game of like, well, maybe it's this. Well, we can rule out that it's, certain types of stars or certain types of remnants of dead stars and other things. And we end up in this situation where there's this very bright, energetic stuff around something that's so very tiny, but apparently so very high in mass, it can't be anything else. So this is one of the probably closest and therefore one of the best studied black holes that's about, I think, 20 times the mass of the sun. And it's hiding. To our eyes, it's hiding in Cygnus. If you have X-ray eyes, it's one of the brightest sources. So kind of fun, yeah. If
you're a superhero, like, I think some of the superheroes have X-ray eyes. I don't know. Maybe they do, but yeah. Not that they're looking for black holes. I mean, they're too busy saving the universe, the planet. So maybe not.
Surely there's some superhero movie where they're like saving us from black holes or something. You just got to know what your risks are, right?
You're in it. That's the next one for the cinemas. Yeah, Megan.
Perfect.
Perfect. Save that. So we've looked at Cygnus, and also the things that we can't see there. I don't know if you might want to look that up later on online. So is that the X1 black hole?
Cygnus X1. Yeah.
Cygnus X1. Okay, so if you want to look that up later, Cygnus.
Astronomers have great names for things, don't they?
Catchy name, yeah.
Oh yes.
We'll come back to that. Yeah, because there's another catchy name as well. Okay, so we've gone from Cassiopeia. So if you're just a beginner to stargazing, it's quite handy because you can see that all year round. Move to the east, to the right, we've got Cygnus the Swan, that very bright kind of cross shape there. And then we've got Vega with the lyre as well, part of this summer triangle that we can't quite see yet. So from there, we're going to keep on going. And can you just about see, can you see my mouse? I think you can.
I can, at least.
Yeah, that should mean everybody else can. So just up here, just up to the right, just above the tower, can you see this kind of, it's like a squashed square shape. It's a bit like a plant pot on its side. Yeah, can you all see that?
Yeah.
As if by magic. We have a shape with all sorts of arms and legs. So this is actually Hercules. So this is in the constellation. Yeah, I know, right? So this is Hercules, the constellation. And if you can see those brighter stars in that squashed shape there, then you're looking in the right place. So once you get to Vega, you're not too far off. So Hercules also contains one of these catchy named objects. Is that right, Megan? What's the catchy name of this one? I think does it begin with an M?
Probably. But I can't remember which M it is all of a sudden. Is this where I have to admit how poorly I know my way around the night sky?
Yeah, I think, there's a little bit of a kind of, is it a running joke that astronomers, you actually don't spend that much time looking up at the night sky, is that right?
It's true. So for me, I can find the constellations where the objects I tend to observe are, because the constellations help me figure if the clouds are going to come too soon, but otherwise, telescopes point at such tiny areas of the sky. That's my excuse anyways.
I'll let you off. So we're looking at M13. So
okay.
Then let me see. So here we go. Let's go to M13. So we should be flying to it now. Here we go. So
is this where I explain what the M is for?
Well, I mean, I would like to think it stands for Megan. Is that right?
I mean, you flatter me. I don't know that I have made that big of a contribution to astronomy just yet. But
I'll just zoom out a bit. We kind of crash landed and zoomed in quite dramatically there. That was, sorry, everybody. So what is this that we're looking at? What is this M13? I'm presuming it's not Megan. Does it mean something else?
No, so the M is for Messier, for Charles Messier. So this was somebody who was a keen observer of the night sky and was, I think, interested in comets, and so wanted to note fuzzy things that were not comets. And so he made a list of them and then numbered them, and that became the Messier catalog. So I guess this is the 13th fuzzy object. And I guess it depends on how good your telescope is as to how fuzzy or not it looks like. So this is obviously a very, very good image from a very good telescope. And we can see it's actually a cluster of stars. And I guess in the spirit of astronomers having great names for things, this is in particular called a globular cluster. So you can tell there's a lot of stars in this. It's pretty dense, looks kind of round. You can see different colors of stars. So you've got a huge population of stars in this pretty compact and pretty old object. So
yeah, I mean, so this isn't something that you could easily see, like if you were looking with just your eyes at the stars. So it's a telescope or something to look for this one.
Yeah, you certainly wouldn't be able to get this level of detail. Depending on your telescope, sometimes you could tell it's a fuzzier object and see a little bit that it's brighter in the center and how it drops in its brightness towards the edges. But
so I'm going to zoom out a little bit so that we can just get a perspective of where we are on Hercules, because it was very quick. There we go. So it's kind of just, here's that flower pot kind of. I don't know why I think of it as a flower pot. If you kind of look that way, it's Is it trapezoid? I can't remember it's been a long time.
That sounds right.
I learned shapes. Yeah. Tell me in the chat if that's wrong. But it's kind of a squash square shape, and then you can just about still see it. This fuzzy blob here was where we were on that M13 globular cluster. I can never say that, Megan. Globular. I'm trying to say that after maybe a gin and tonic or something. There's no hope. Cool. So we'll anyway, we'll zoom back out. There we go. So you can see where we've come across the sky up to Hercules. Okay, so I've got another question for you all watching. We haven't forgotten you watching. Don't worry, I can feel that you're still there, and we're going to ask you another question. So pop in the chat if you've got any thoughts on this, Megan as well. What kind of things, you said all these things that you're exploring, things you're finding out about, in your job. What are the most kind of exciting mysteries about the universe that we still don't know about, do you think? Is there anything particular like, ooh, that would be really good if we could find that out? What are your thoughts on that?
I mean, I think that's a great question. Should we see what folks in the chat are saying? I don't want to take up all the airspace.
Yeah, sure. Well, wait a second.
Yeah.
I'll tell you mine. So I think, well, John says dark matter and dark energy. I mean, these things come up all the time, don't they? So I'm just moving the screen around. So yeah, things like that. I mean, just because it's so unknown, black holes, these things that you can't necessarily see, we don't really understand what's going on. String theory, yeah, good one. Land back on the, going back to the moon, yeah, someone says. So let me say that, because I think at the moment, my kind of thinking is like, will we be able to make other places in the solar system habitable? Will we ever go, will we go back to the moon? There is talk of that happening in the next few years. Mars at the moment, you may be watching the news, but there's all sorts of exciting things. The news today I read was that is it Perseverance, the mission on Mars at the moment? It's the experiment for converting CO2, so carbon dioxide, to oxygen was successful. So I mean, is that something that's useful, going to places like Mars or the moon? Is that something that you think will happen? Do you think we'll ever be able to get a ticket for an Airbnb of a hotel on the moon? What do you think?
I mean, I think that's a great question. I think being able to convert the carbon dioxide that's already onto Mars into oxygen that humans would need to breathe is a big step to enable that kind of thing. Just, you're always limited by what you can carry, and I think you're limited in what you can carry by what it takes to get out of Earth's gravity. So I think the more that we can make for ourselves when we arrive, the better the chances are that people could go for longer term and go for pleasure, those sorts of things. And I think that's actually a really nice tie to one of the things that I think is also really exciting happening in astronomy now, is just thinking about planets around other stars and trying to ask the question a little bit about what it would take for them to host life, and how we can detect that using just our telescopes and just the light either that we get from the planets directly, or from how they absorb the light of their star, in order to figure out what kind of planets and whether or not there's life there. So I think that's both a really exciting bit of science and a really exciting debate about how exactly can we do this.
Should we go and visit the moon? Why not? I mean, it's looking pretty nice at the moment. If you get a clear sky, let's have a little look. So I think we should be able to go and see the moon. Let's have a look. So
that's still the only place other than Earth that humans have ever visited. So
yeah, it's crazy when you think about it like that. Here we are. So if you're new to stargazing as well, get a pair of binoculars, even just use your eyes, look up at the moon. It's a really good place to start, especially at the moment. So when you can see half of the lit side, so it's always half it's in the shadow, half it's lit, but it's always the same side that we can see that's facing us. So you can see we've got this I forgot the word shadow then. The shadow, the shadow across here, this bit where the light meets the shadow, that's actually called the terminator. Like, my favorite thing I ever learned about astronomy was that is called the terminator. Don't know who named it that, but brilliant. It always makes you laugh, Megan. So this is a really good place to look for detail, which you may know if you've looked at the moon before, but just in case some of you are new to this. So you can see you get all these shadows in the craters, and if you just use some binoculars, look up at the moon, you'll see all sorts of things. And if you get a moon map or look up online, Google moon, you can find out what these things might be that you can see as well. So it's a really good place to start with beginner stargazing. And it's, thinking about, will we go back there again? And Megan, is it right that it might be taking this sort of telescopes on the moon? Is that something that is happening. Is that right?
So I think so. So I was aware there's a lot of enthusiasm for putting telescopes on the moon, and it sounds like things might be further along than I realized. So I think some initial probes are maybe down, and they're trying to figure out how do you send the signal back to Earth. But a lot of astronomers would be very interested for telescopes on the moon because it gets around to the really big problems that you have trying to observe certain wavelengths from the surface of the Earth. So no atmosphere. So certain wavelengths of light are blocked by the Earth's atmosphere, and that's simply not a problem on the surface of the moon. And then you're away from humans, which say at long radio wavelengths, if you're interested in the really early part of the universe, human radio communications just completely drowns out the astronomy signals. But if you're on the moon, you're far away from all of the human radio noise, and you have a hope of detecting this signal from the very early universe. So I think that's one of the main science drivers at the moment. But I think there are a lot of people being like, oh, interesting. If you want to observe ultraviolet light, also you have to get above the Earth's atmosphere. I wonder if we could do ultraviolet light from the surface of the moon. So I think, yeah, a lot of curiosity. This might be a real growth area.
Yeah, exciting. That's cool.
Oh.
Yeah, you don't really think of taking telescopes to them. I'd never thought of it before. It's kind of sending them into space, yeah, but actually taking them to another body in space or another place in space to actually sit them down there and use that to observe. Pretty cool.
Yeah.
Okay, so let's just go back out from the moon. So we'll zoom back a little bit, and there we go. So we're back on the rooftop here. So we're going to look at another couple of constellations patterns that you can see at this time of year. First, we're going to go back, like we did with Cassiopeia, to one of these circumpolar constellations. So one that you can see all year round, and that's a really good signpost for some other constellations. So this one is, we're actually facing the south at the moment. But if you just look up here, you may know this as the plough or the saucepan. You know, it does look like a saucepan. Can you see it's got a handle here, and then it's got these, yeah. And this is actually an asterism. So that's part of that just means that it's part of a constellation. It's a fancy word you can show off to your friends. And this constellation is Ursa Major. So here it is, the weird looking bear with the longest tail you've ever seen. But this is a really good pattern to know about because, because it can point you to some other patterns as well. If you tuned in last month, you might remember this rhyme. It was arc to Arcturus and speed to Spica. So it's a bit like the rhymes that you learn at school for the planets. It's quite a catchy one, and I always remember this. So hopefully everybody watching, this is a handy thing. So it just means that you go from the panhandle or the handle of the plough or the bear's tail, and you arc to Arcturus. So you kind of arc down this way, so going down towards the horizon, and you get to this very bright star here. So that's a star that's part of another pattern called Boötes, which is this guy here, and this star is called Arcturus. So arc to Arcturus, and then we speed to Spica. So we're going down towards the horizon again, down towards the ground. And so we speed, so we go all the way down. And can you see there's quite a bright star here? You just about see that? Yeah, are you with me, Megan?
I see it. Yeah, I'm carefully studying here. Am I going to remember this when I go out later tonight? Okay, arc to Arcturus, speed to Spica.
Arc to Arcturus, speed to Spica. Here we go. Okay. And Spica, these stars, they're actually part of something called the spring triangle, which isn't really something people talk about much, but there is another spring triangle as well. But this one is Virgo. So you might know that if it's your star sign. It's my star sign if you're born in September. So Virgo, the constellation, here it is a good one to know as well. Now it's quite, and the glare from the lit side of the moon is quite bright if there's a lot of that side we can see. So when it's a full moon or quite a bright a lit moon, so it doesn't make its own light, but the reflected light from the sun. You might not be able to see all of the stars around it very well, but you should be able to see this very bright one down here. So Spica's pretty bright and easy to spot. So we're facing south at the moment. Now, Megan, I think there's something else that we can, another one of these Messier objects. Is that right?
Yes,
Virgo.
another fuzzy blob, but a different type of fuzzy blob, right? Yes.
Yeah.
So if we go diving in, we get to, what is it, M87?
That's the one. Let's have a go. Here we go.
Zoom in.
Yeah. Ooh, okay.
Oh, neat.
Yeah, we've been clever, and Kieran, who's in the background, has added in a couple of pictures. I can't claim I did this, but Kieran very handily has dropped these in for us, because Megan's going to talk about one of these. Well, you might know this image from the news. It's been in the news, the one on the right, quite a lot recently, right? What is this thing here that we're looking at down here on the right?
So this is exactly one of those indirect pieces of evidence telling you that there's definitely a black hole there. So the bright stuff is actually material orbiting the central black hole, which we can't see because nothing can escape a black hole. But I think one of the powerful things to know about this kind of image, the dark spot in the center is about the size of our solar system. And that's in another galaxy. So one, in terms of the technology, the astronomy, that is so freaking cool. That also tells you that this is a very, very tiny area where there's no light escaping. But the way that this material is behaving tells you that it's got to be a very massive thing. So again, very strong evidence that there's a black hole at the center of this galaxy. I think Kieran's done a really great job pulling up images here, because I think one of the reasons that we knew.
There we go.
Yeah. Oh, better. Yeah. So is it just off the top here we can kind of see the galaxy itself? So it's
so whereabouts is M87? Which one of these? Because what are these all galaxies? These little blobs here? Are these stars? What's going on here?
I think most of these are galaxies. I think kind of just to the left of your cursor, going down towards the bottom of the screen is actually M87. So that right there. Yeah.
This one here. Okay.
So it's sort of a big.
Yeah. There we go. So this bright one here. Yeah.
And it looks like there's maybe a little bit of something fuzzy coming off the galaxy, and that's actually this jet where Kieran's put the picture on the left. That is such a great picture of the jet. Thank you.
That a real image then? Is that a Hubble image, or is that?
Oh, that's a great question.
I think it is. I think it is a Hubble image. Yeah. So what does this show then? What is this thing coming out of?
So it's a jet driven by the black holes. So we only partly understand what's happening here, but as the material is orbiting around the black hole, some of that is falling into the black hole, but some of that actually gets redirected into this jet. And these jets are huge. So you can see them in images that tell you that something very interesting is happening deep inside the galaxy. And you can sort of study the jet itself to get an idea of what might be happening. And this is also a very good indication where to be looking for black holes. So kind of a nice story, kind of a nice putting together the pieces of the puzzle, trying to chase down what's happening with this particular black hole. So then we can go with the Event Horizon Telescope and get this image of the material around the black hole. And I think the newest information, if you can see, there's some thin lines, kind of looks like hair around the black hole.
It's just wispy bits here. That's new, right? Because the image I've seen before didn't have that on. Is that a new addition?
Right. I think those results just came out a few weeks ago. And those are measures of the polarization. So if anybody has polarized sunglasses, it's good fun to go outside and sort of turn your head 90 degrees and then put your head back up. And you can see that your polarized sunglasses are filtering out some light, particularly off of reflective surfaces. But that same kind of method, that certain polarizations of light will trace different things. So in this case, the polarized light tells us something about the magnetic field in the material around the black hole, which is important for understanding, one, how you get to this jet, and then what's happening with the black hole itself. And again, this is, a tiny little object in another galaxy. So I think a pretty incredible technological achievement.
Crazy. So how big is this? You said they're pretty big. How big is this in terms of what would the Earth be like a tiny speck on this then? Is this like the size of our, what?
So I think the central dark part in the middle of the donut, is there a better term for this kind of cool thing? Yes.
Space donut. I like that. Anyone in the chat, let us know if you've got any other ideas for what we should call it. I like space.
That's right. But I think, that dark central region is like 1 or 2 times the size of the solar system. So Earth itself wouldn't look very big at all on that image, but I think relatively speaking, that's still incredibly small, especially given the distances that we're talking about.
Yeah. I mean, this is like so new, this. I mean, when I'm trying to think when the Event Horizon image was released, was it a year ago, a year and a bit ago? Is it that long ago? I have no perception of time now since everything's going on in the world. A year or 2 years.
I think it was 2 years ago, but it's very recent, yes.
And I mean, like when you started in your career or learning about astronomy, did you ever think there would be something like this? Was this like, you know, complete like fairy tale land, or was this something, how do you feel about that now, how far things have come? Like,
I mean, I think it's amazing. So this image is taken at a similar wavelength to one I used for observations for my very first paper. And it's funny to see like the resolution of those observations was very, very coarse. Like there was a blob there was about as much as we could say. So, you know, in just over a decade, we've gone from being able to say, like, I can compare different blobs to being able to actually see the material around the black hole in another galaxy. And one of the things that's so amazing to me is the telescope that I used for that first paper was part of making this image. So I think this was such a clever idea. Let's use telescopes that already exist, put some new electronics on and get them to work together like one enormous telescope. And you can do things like that. Like, I just think it's such a clever idea.
So cool. So cool. I've noticed some people have put some questions in the chat. I think Kieran's doing a great job answering some of them for you, but if you do have other questions, we'll have a little bit of time for that in a moment. So please use the Q&A button if you've got any questions for Megan. So I think we'll go back to the night sky. So should we zoom back out again? Let's go back in. So, there we go. Okay, so we are quite late at night now. I mean, we're nearly midnight now. So what I'll do is because we've had quite a good tour of the night sky, a few things we've looked at there. So some things to look out for all year round, those circumpolar constellations. So Cassiopeia, the W shape, and also the Plough, Ursa Major, and then those other seasonal constellations. As I said, this is recorded, so you can always watch this back later. At the end, we'll put the information up where you can do that. So don't worry if you didn't catch everything and you're like, oh, I've missed it all. I didn't, you know, what was she talking about? You can go back and watch it and catch up as well. Right, okay, so I think it's time to go to a beautiful sunrise. So let's have a look at a beautiful sunrise. I'm going to face over in this direction. There we go. Let's see if we can fast forward time a little bit. There we are. So you can see as the Earth's rotating, the stars appear to rotate in the sky, and there we are. We've got a beautiful sunrise, and we can see the rooftop again, and the beautiful telescope dome here, and we can also see the city of Edinburgh as well. There we are. So that's the end of our night sky tour part. I'm just going to stop sharing my screen because we've got a little bit of time for questions. Okay, so notice some of you have submitted questions already, but if you've got any other questions for Megan, use the Q&A button to submit a question. And someone in the chat's asking if we could read out the questions and answers. Yeah, we will. So if you submit them in there, we might not be able to answer them all, but we'll read out the question, and then Megan will put you on the spot here. Megan will answer the questions. Now, the thing is with any, you know, any scientist, anyone in the world, you know, we don't know the answers to everything. And the great thing about astronomy is that there's so many mysteries still out there. So, you know, we'll answer the ones we can, but there might be some things that are, you know, if you're younger and watching, you might find the answers when you're older. Or I mean, a lot of astronomy, there's so many discoveries that have been made by amateur astronomers. I say amateur when, you know, I mean, it's people that are doing astronomy, say in their backyard garden or their backyard. So, you know, it's not just the experts or people, you know, that are I say, I'm trying to, you know, everyone is a scientist, yeah.
Especially now that we're getting into an era where there's just so much data, people who are very good at looking at images and know what they're looking at have made such big contributions by being like, wait a second, I can tell that that's something different, or I can see that there's something interesting there, and they flag it up. And that's been huge, I think, for moving things forward.
Yeah. Cool. Right. So let's have a little look at the questions we have. Okay. So the first question we have is, how do we gather information on black holes? What data are we looking for?
That's a good question. So there are a few different ways to go about it. And a lot of that is, I think, kind of indirect information. So we looked at that picture from the Event Horizon Telescope that's looking at emission of things going around the black hole. And some of that material will eventually fall onto the black hole. Some of that will get kicked out by the jet. So studying the material around the black hole can tell you part of what's happening with the black hole. Studying those jets can tell you part of what's happening with the black hole, because that's an important part of how those jets get made and get so powerful and so big. I think one of the things that's been really powerful looking at the central black hole of our own galaxy has actually been looking at the stars that are very near that black hole. And people have been watching for more than 20 years now with incredibly high quality images. You can actually trace out the orbits of different stars around what looks to be a very, very tiny point. But the stars are moving so fast, you know that whatever they're orbiting around has to be very high in mass. And so this is some of the best evidence that we have for the presence of the black hole in the center of our own galaxy. And I believe that this was some of the work that was recognized with the recent Nobel Prize in Physics. So yeah, good stuff.
Good stuff. I'm just sorry, I'm smiling at the chat because Kieran's let me know that he says, shout out to the green peas, which is the type of galaxy discovered by the public in the late 2000s, which Kieran's also an astronomer as well, and he did some work on. So green peas, there you go. Do you know about the green peas, Megan? I've never heard about that.
Yes.
Tell me about that.
It's exactly a case of these things look a little bit weird. And in fact, the galaxies look like green peas, depending on how you make your images with different colors of light. And the fact that they look green instead of looking kind of whitish or reddish or other sort of colors tells you that there's something very interesting going on in the kind of emission that you're getting from these galaxies. So the question is why? And so astronomers have actually been tracing that down, trying to figure out, and they're pretty exciting, kind of funny little systems.
Yeah, I mean, if any of you are interested in citizen science as well, which is basically, doing science yourself at home for all sorts of different things, it's using the power of people to gather lots of data and analyze that data. There are some great projects to do with astronomy. Big one is Galaxy Zoo, but there are also lots of other projects linked to that as well. So, you can categorize galaxies and analyze real data and help the science as well. So yeah, there's a lot of power in people with science.
Yes.
Okay, I think we've maybe covered this question. Someone else is asking what a black hole does to a galaxy and how does it affect it? Is there anything else you want to say about that? I think you've already talked about some ways it affects it.
I think some ways, maybe the only other thing to say is that there are certain properties of a galaxy that do seem to be very related to the properties of the black hole. And it's a very active area of research to try and understand why those things are so closely related.
Yeah. Okay, so another question about citizen science. Can you do citizen science if you're a complete astronomy beginner? I would say yes. A big yes.
And I think
I'm not an astronomer. Sorry, Megan. I'm just going to say I'm not an astronomer. But I've learned astronomy through my job and through things that I'm interested in. And all of the citizen science projects, especially Galaxy Zoo, they have guides and it shows you what you need to look for, and it's really easy. And I don't think you need to be, an expert in astronomy at all to take part in it.
I was just going to add that if you're interested, I think it's actually a really great place to start because they do have so many nice ways of introducing you to the project and to the kind of data and objects that you'll be looking at. So yeah, it's a really nice resource.
Okay, so we've got time for a couple more questions. What was your first telescope type? Someone's asking. So I guess the first telescope you worked on, you said you don't really look at the star. I'm guessing you didn't own a telescope, or did you? Or tell me about that, Megan.
Not really.
Straight to the big ones. You're like, I'll just use the big telescope first. Forget this.
So the first, well, I guess, yeah, I think the first time I looked through a telescope was with the Girl Scouts, and it was cloudy and it was cold and I wanted to go home. So I certainly couldn't tell you what kind of telescope that was. I remember there was a telescope on the roof of the astronomy building when I went to college, and I do remember looking through that. That was very cool. I don't remember what kind of telescope. So the telescope that I used for my first paper was a 10-meter radio telescope in Arizona, very imaginatively called the submillimeter telescope.
Astronomers with their names for things. Usually it's an acronym that spells out something fun, but
yes.
Cool. Okay, let's have a little look. So some people are asking about how to observe the sun. I think Kieran's answered it in the chat. I think, yeah, just be very careful. Obviously, don't look at the sun with your eyes without anything at all. Yeah, look, I think Kieran's put ideas of using special filters and things that are made for looking at the sun. It is very easy to do. You can create solar viewers very easily. You can buy them quite cheaply, but yeah, just make sure that you get the right kit for that. Yeah, let's have a look. So I think there was a couple more. Any astronomical societies or astronomy or astrophysics websites that you would recommend? So I mean, we're in Edinburgh, so we have the Astronomical Society of Edinburgh. Even if you're not based in Edinburgh, they have a really good guide. I think it's called, is it 4 Steps to the Stars? I'm trying to think how many steps to the stars, but they've got a really good guide in starting off, things to look out for if you're beginning in stargazing. And also they have handy guides for kit, so for telescopes that you might want to buy. So yeah, I would definitely check out the Astronomical Society of Edinburgh website. But obviously where you live, if you just Google Astronomical Society of insert name of place where you live, there probably will be lots of other local astronomy societies, and I'm sure they'll be more than happy to chat to you and help out because they're great bunches of really knowledgeable people. So Megan, would you add any other websites or cool places to go?
I mean, I don't have very practical suggestions, but I do love the astronomy picture of the day. I think that's from NASA. Just if you NASA APOD, yeah, a daily bit of awesome.
Yeah, let us know if you've got any other sites, everyone. I mean, you could go probably on all day talking about different places to find astronomy information. There's Heavens Above is quite a good one that I use quite a lot, which, you can look for when certain things are in the sky. Stellarium, obviously, that's a great place to start because you can look at any time or date and you can check ahead what you might want to look out for. So yeah, I think, is there any other questions? I think let's have a little look. We do have oh, thanks, Kieran. He's popped the link in the chat for everybody. Okay. Oh, I like this question. So this is from Pamela. Do you have any favorite astronomy space movies or books? Doesn't have to be documentaries, could be fictional. That's a nice question to end on, I think, Megan.
Oh, do I have any? I mean, I really loved Gravity. I know the science isn't perfect.
Does that annoy you, or do you just let it go?
I think for me, the thing that matters, like if I'm invested in the story, it's okay. If I'm really annoyed about the silence, I've clearly lost interest in the characters. Yeah, I'm trying to think. I think there probably are other fun sci-fi movies. Oh man.
You'll think of them afterwards, I bet. Yeah, I'm trying to think.
Yeah. Good fun space movies. I don't know. This is embarrassing. I'm totally drawing a blank. My goodness. It is a great question, though. I don't know. So I'm going to cheat and suggest a TV show. I enjoyed Firefly also, where they're skipping around different planets I think in the same solar system, but maybe they're doing intersolar system travel. Yeah, that was a good show.
Cool. No, I like that one. Cool. Okay, so I think we'll finish there. We've got, I think we've answered most of the questions. Yep. Any other questions? No, just people being very friendly and nice and saying thank you, which is lovely. We're so glad that you could all join us. And big thanks to Megan. It's been great to chat with you and explore the virtual night sky together. I hope you've enjoyed it. Have you had fun?
Yeah. Thank you so much for having me. This has been great. Yeah.
Oh, good. I'm glad. So I hope you've enjoyed watching wherever you are in the world. And I hope that it's inspired you to, take a look at Stellarium, have a look at what you could look out for, and watch this back, watch some of the other episodes back. you know, and maybe even venture out and look at the real night sky, even if it's just for, you know, that little escape at the moment, now that we can travel a little bit further and just to, yeah, see the bigger picture. So it's a nice thing to do. Right, I am going to share a little bit of information for you all before we leave. So if you just bear with me, everybody, just to show you where you can find out more about some of our other events. So I hope you've enjoyed watching. If you want to follow us on Twitter, it's @RoyalObs, and we share lots of different things and mostly events that are coming up. So I think Kieran should have posted them in the chat, if he hasn't already, he probably will very shortly, about our upcoming events. So if you're watching this live, we have an event coming on Monday. So on the 26th, we have an astronomy talk, if you want to join us for that. It's about, I think it's active galactic nuclei. There you go. So related to the black holes. If you want to find out more detail about that, with one of our other astronomers, Phil. So that's something to look forward to. So that's more of an in-depth talk about that topic. And also our next and final one of these for a little while will be on the 20th of May with another astronomer called Ken. So we'll be exploring a few different things, maybe the summer triangle, some different things in the night sky as well. So if you want to check out any of our events that are upcoming, other things that we do, go onto our website. It's just up there. It's www.roe.ac.uk/VC. And also, as I said at the start, this is recorded, it's live streamed to YouTube, so you can watch again, and you can find all the other episodes if you just search for STFC, so it's Science and Technology Facilities Council, which you can see on the bottom right of the slide there. But just search for STFC YouTube channel, and you should find all the previous ones. And also there's lots of other great videos about some of the really cool science and technology and things that are happening all over the UK. So do check it out. But other than that, thanks again, Megan. And thanks everyone for watching, and enjoy the rest of your evening, and take care. See you soon. Bye, everybody.
Thank you.
Bye.